topic of this video is the preparation of a crude extract. There will be 5 parts. So what's your starting material? Have a look at the extraction buffer. We will choose a lysis method for tissue disruption. You have to centrifuge your samples in order to get rid of debris, to get a clear solution, and make decisions on sample storage. In July, I went into the lab and prepared a crude extract from banana pulp. So have a close look at the starting material. In your description, include coloration or any other information that you can glean from the label of the bananas. For this experiment, banana pulp, the interior, and the peel of the banana were separated so that only the banana pulp was used to prepare the first extract. 2 bananas are too heavy for the scale, the weight limit, so both pieces had to be weighed individually. The weight limit is 200 grams. In addition to the bananas, your solid starting material, you also need an extraction buffer. Sometimes it's called lysis buffer. An extraction or lysis buffers have multiple components, not just the buffer itself, but also often salts, detergent, protease inhibitors, antioxidants, or metal chelators. Not every extraction buffer has all components. As you'll see, the extraction buffer used in today's experiment is much simpler. The extraction buffer used to prepare the banana pulp extract was a sodium phosphate buffer at a pH of 7.3, molarity 0.1, and 2 millimolar ascorbic acid and antioxidant was added. There are different methods to disrupt the tissue of the banana pulp. We can also call the state cell lysis. Some are mechanical, others non-mechanical. Non-mechanical methods often involve the addition of further chemicals that will then also be part of your experiment. So for the banana pulp, out of all these decisions, we used mortar and pestle. One thing to keep in mind is to always keep your solutions on ice and to pre-cool all equipment. So here are the pre-cut banana pieces, the lysis buffer. Don't add all lysis buffer at once. Small portions are crucial because you need to have enough traction for your pestle to first get your banana all mushed up almost into a paste, and then you can gradually add more extraction buffer. To get rid of the debris, you can first filter through a cheesecloth and then press out any remaining solution. Needless to say, this part can get rather messy, so definitely wear your gloves, and it's always a good idea to reserve some of your extraction buffer so you can keep rinsing, and you also want some extraction buffer for balancing your centrifuge tubes. But at the very end, please note the final volume of extraction buffer that you used. To get rid of any remaining debris, we use a centrifuge. Here, the rotor that was used is called F14, 6 times 250Y. The 250 describes the size of the centrifuge tubes, and the 6 is the number of the tube. It is very important to balance the centrifuge tubes that you put in opposing slots. So even if you don't use all 6 in opposing slots, the centrifuge tubes need to have exactly the same weight. This slide also contains the centrifuge setting. So the speed of a centrifuge can be expressed in revolutions per minute. or in units of relative centrifugal force. After this one, which was 30-minute long, definitely be ready with your ice bucket. And then when you pour, first pour into a beaker, into a large beaker, and not directly into the cylinder, but later you can measure with the cylinder. Finally, distribute the sample into aliquots. You can have different size of aliquots. They don't all need to be the same, so that you can thaw them in the portion size that you need for your next experiments.